Saxon's Trig, lesson 26, is about the logarithmic form of the exponential and logarithmic equations. Begins on page 183. So the logarithmic form of the exponential, I'm going to start it this way and give you an exponential form of something. Okay. So what we're doing is we're taking something that's written with an exponent and we are rearranging it into its log format. So the base of this, whatever the base is that has the exponent, becomes the base of the b, which is written little here beside the word log. And we'll get to our calculator button that deals with log here a little bit later. Right now, they want you to understand how this thing rearranges. The answer part is the large number beside the log statement, and it equals the exponent piece. So I can go from the log format back to an exponent format to help me solve, or I can go from an exponent format to a log format. Now on your calculator, the log button itself implies that the base here is the number 10, and then there is another natural log button which we get to later. But right now, they want you to learn how to rearrange, and the log won't necessarily be a base of 10, but if you're using the log button on your calculator, you are forcing it to have a base of 10. So example 1 on page 184 gives you 4 equals 3 to the y, and it says put this in its log format. So you're going to write log, the base is 3, the large number is 4, the exponent is y. You've rearranged it. So solving this one does not work very well. Solving this one is much easier. I have the y, and this I can punch into the calculator. I can't use the straight up log button because the base is 3. You have a different button if you need to be doing the solving, but for right now, they just want you to write it this way and not worry about solving it any further. Example 2 gives you log base x 4 equals m, and they say put this in its exponential format. The base is x, so it will remain the base. The equal part is the exponent, and it will equal the large number, which is 4. So now you're asking yourself, what base to what power would give you a 4? But we're not solving in this, we're just doing the rearranging. Part B, the logarithmic equations, now says let's work a little bit on solutions. So log base b of 8 equals 3. So I need to rearrange to its exponent format. B to the third power equals 8. Oh, this I can definitely solve. What number 3 times gives me 8? B is 2. That means 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So that works. Example 4. Also given in log form. B9 equals -1/2. The base is b, the exponent -1/2, and it equals the large number 9. Now I can't deal with an exponent that is negative here and do the solution. So there are a couple ways I can think my way through it, but I feel like the easiest one is I want this to be b to the first power so that I know b equals such and such. So how do I go from -1/2 to a +1? I multiply by -2. Negative times negative is positive, and 2 times 1/2 is 1. And if I go to the negative second on this side to make it work, to balance it, I need to keep the other side having a -2. Now, how can I solve this? Negative exponent means I change the location of the number. So instead of being the implied 9/1, it's 1/9, and the squared is now no longer negative, it's just squared. So b equals 1/9 squared is 81. Example 5, log base 3, 1/27 equals m. Rearrange to the exponent format. 3 is the base, exponent of m equals 1/27. You are to find what the exponent is. So it has a base of 3, but in the answer, the large number is in the denominator. That tells me my m is going to be a negative of some sort because it's moving it from the numerator to the denominator. 3 how many times turns to 27? 3 times 3 is 9. 9 times 3 is 27, so that was 3 times. So my m will be -3. Example 6. Solve of log of 1/3 for the base p equals -2. Again, rearrange. 1/3 is the base, exponent is -2, and just to clarify, I'm going to put it in a parenthesis, equals the p. So this has a negative, which I need to remove, which means I'm changing the location of these things. So it's flipping over and becoming 3, and now it's no longer negative, squared equals p, and 3 squared is 9, so my p is 9. Example 7, log base 4 to the 8 equals x. Rearrange. 4 is the base, exponent is x, and it equals 8. Now this one is a little touch different because 4 to a certain power does not give me 8. So I need another way to think my way through this. Can I change it to have the same base? Oh, 2, yes, because 2 squared is 4, and that has another exponent of x. One base with 2 exponents, you're multiplying those parts together, so it's written as 2x equals 2 to what power is 8? 2 times 2 is 4 times 2 is 8, so 3 times. Now that they share the same base, I can ignore the base and just solve 2x equals 3. Therefore, x is 3/2 because you divide to separate it. So that one is a little more complicated. You might not have instinctively known how to solve it, but now that you've seen it, anytime it's not working nicely, see if you can turn it into a base that is the same.